Use of bar graphs and line graphs. Contents. Introduction. Bar graphs. Line graphs. Conclusion. Introduction. Writing down information into a report is not always the best way to express information. It also becomes difficult to make intelligent comparison between quantities and grasp the facts represented by them when their number is very large, even if they are given in a tabulated form. In order to convey the facts of a large number of figures to be grasped clearly and quickly, we resort to represent them by geometric figures like bars, rectangles, squares, circles, cubes, spheres, and curves. These geometric figures are called diagrams. Overall, these diagrams serve the following purposes. They enable us to compare figures at a glance. They can be easily memorized. They can also help in analyzing data and drawing inferences easily. In fact, the study of climatic, economic, and population data in geography has been immensely benefited from the adoption of statistical procedures in its spatial analysis. Geographers often use graphs because they are a simple yet effective way of showing statistical data. It is important for students to be familiar with a variety of graphs since each one is best suited to represent certain types of information. In this episode, we are going to study about the uses of bar graphs and line graphs. The following modules are covered. Bar graphs, characteristic features, structure of bar graph, methods of construction, types of bar graphs, advantages of bar graphs, limitations. Definition. Before we approach the understanding of bar graphs, one should grasp what graphing refers to. Graphing is a pictorial way of representing relationships between various quantities, parameters, or measurable variables in nature. A graph basically summarizes how one quantity changes if another quantity that is related to it also changes. A graph is the most conventional representation in which a series of points are plotted by means of either Cartesian, x and y, or polar, r and theta coordinates on reference frame of a chosen origin. Bar graphs are one of the many techniques used to represent data in a visual form so that the reader may readily recognize patterns or trends. There are several types of graphs such as biaxial, triaxial, multiaxial, and special. Now, let's unfold the meaning of bar graphs. A type of biaxial graph is a graphical representation of data in which typically bars of uniform width are drawn with equal spacing between them on one axis, say the x-axis, depicting the variable or the specific categories being compared, while on the other axis, say the y-axis, the values of the variable are shown and the heights of the bars depend on the values of the variable. Thus, bar diagrams represent quantities by bars or columns. Characteristic features. In these diagrams, quantities are represented by bars, the length of which are proportional to the quantities they represent. The width of each bar is fixed according to convenience and is not proportional to the quantity a bar represents. Here, time is fixed and the unit of area or production varies. The important point to note about bar graphs is their bar length or height. The greater their length or height, the greater their value. Given one variable, the value of the other can be easily determined. All bars have the same width, that is equal intervals. The equal intervals are shown on one of the axes. The frequency of the data in each interval is represented by the height or length of the bar. The tops of the bars reveal the rise and fall of the totals, but the presence of bars directs the eye to the actual quantities. Bar graphs are used to display data in a similar way to line graphs. However, rather than using a point on a plane to define a value, a bar graph uses a horizontal or vertical rectangular bar that levels off at the appropriate level. Structure of bar graph. A typical structure will have a title, label, axis, scales, and bars. The title refers to a few key words that explains what the graph is about. Label. Both the side and bottom have a label that tells what kind of data is shown. Axis. The x-axis is the line running from left to right as it is horizontal. The y-axis is usually the line that runs from up to down as it is vertical. The x-axis shows what type of data each column represents, and the y-axis shows a value for the type of data. For example, in a rainfall graph, each column on the x-axis represents a month of the year, with the height of each column on the y-axis showing the amount of rainfall in that month. Scale refers to the numbers that show the unit used on the graph. Bar. A bar is like a ruler that measures the data number. Methods of construction. Step 1. Draw the axis. One should include the range of your data. Students are advised to draw bar diagrams on a piece of squared paper. Step 2. Mark the intervals on the axis. The interval between the values of the quantities shown should be chosen carefully. The figures representing the quantities should be rounded off. Each division of the scale should represent the values in whole or round numbers. For example, 0, 10, 20, 30, 40 lakh tons. 0 should invariably be shown. The division should vary from 5 to 8 in number. Step 3. Draw a bar for each category based on the data. The individual bar should neither be very wide nor very narrow. Each bar should be of similar width. The bars should be equally spaced also. The spaces separating the individual bars should not be more than the width of each bar. In the case of a bar diagram showing monthly rainfall, the bars are sometimes placed adjacent to each other. Step 4. Give your graph a descriptive title. It should be written at the top or at the bottom of the diagram. All words and figures should be written horizontally to facilitate the reading of the diagram easily. While drawing the bar diagrams, the following points should be kept in mind. The length of the various bars are calculated from a baseline indicating the starting point, that is 0. If the bars are vertical, the baseline is horizontal, and if the bars are horizontal, the baseline is vertical. The names of the districts, states, etc., or months, years, etc., are written along the baseline, and the values of the quantities along the other line when the bars are vertical. Like most graphs, bar graphs have a horizontal and vertical axis. Bar graphs also use the graphical convention which requires that the scale, that is the number line, always increases in order and by the same amount. For example, 5, 10, 15 or 1, 2, 3. The scale of a bar graph is always placed on the horizontal axis and information is shown using horizontal, that is left to right columns. When constructing a bar graph, it is a convention for the bars to be drawn in order of length, that is the longest at the top to the shortest at the bottom. Types of bar graphs. There are various types of bar diagrams, but we shall discuss the given ones. Simple. It consists of a series of bars, each of which shows value of only one variable. We can represent, for example, the total population of different states for a particular year, the annual production of wheat for some years, and monthly rainfall of 12 months of the year. Comparative or multiple bar diagram. Multiple bar graphs visualize the different objects of study under one particular limiting condition. For example, measuring rainfall in two countries over the same period. This diagram consists of a series of simple bars representing quantities of the same category by sets of two or more different bars. Since a set of bars represents the quantities of a particular year, bars of a set are placed close together. Compound. In this diagram, first we make simple bars for each class taking total magnitude in that class and then divide these simple bars into parts in the ratio of various components. This type of diagram shows the variation in different components within each class as well as between different classes. Subdivided bar diagram is also known as component bar chart. Suppose the land use data of India is depicted category-wise for a particular year. A compound bar diagram may be drawn to show different categories by subdividing the bar. Then erect the simple bars of each year based on the total value for each. Further, subdivide each of them according to percentage figures. The total length of the bar will represent 100 units, and on it subdivisions are made showing the shares of each crop in a year. Bar graphs are used to compare facts. The bars provide a visual display for comparing quantities in different categories or groups. However, bar graphs can be difficult to read accurately. A change in the scale in a bar graph may alter one's visual perception of the data. They are also drawn on maps for showing regional variations in the distribution of a quantity. Bars can also be located within the regions of a country or within countries if the purpose of the diagram is to show variations. Advantages of bar graphs. When compared with other diagrams, the bar diagram gives more accurate idea of the size of the quantities represented by them. There are many characteristics of bar graphs that make them useful. They make comparisons between different variables very easy to see. They clearly show trends in data, meaning that they show how one variable is affected as the other rises or falls. Bar graphs help us to see relationships quickly. These diagrams are easy to draw and easy to comprehend. Limitations. When the quantitative variables are too wide, the visual appeal is lost. They are simple to draw but represent only one dimension or characteristic of the data. It requires additional explanation and can be easily manipulated to yield false impressions. It also fails to reveal key assumptions, causes, effects, or patterns. Simple bar diagram. It cannot be drawn when there is a great difference in the values of the quantities and when the number of bars to be drawn is very large. Comparative or multiple bar diagram. In this diagram, the total of all the quantities of a particular year is not shown because the quantities, though belong to the same category, are of different kinds. Line graphs. Definition. Characteristics, features. Structure of line graph. Methods of construction. Types of line graph. Advantages of line graph. Limitations. Definition. Line graph, also known as a line chart, is a type of biaxial graph that is drawn on a reference frame of two mutually orthogonal axes. It is a type of chart which displays information as a series of data points called markers, connected by straight line segments on two axes. It also shows how a particular data changes at equal intervals of time. The line graph, therefore, helps to determine the relationship between two sets of values, with one data set always being dependent on the other set. Characteristic features. Each type of graph has characteristics that make it useful in certain situations. Some of the strengths of line graphs are that they are good at showing specific values of data, meaning that given one variable, the other can easily be determined. They show trends in data clearly, meaning that they visibly show how one variable is affected by the other as it increases or decreases. They enable the viewer to make predictions about the results of data not yet recorded. Structure of line graph. Look at the example of a line graph below. Based on the analysis of this graph, different parts of a line graph can be listed. The data. The most important part of your graph is the information or data it contains. It can present more than one group of data at a time. In this graph, two sets of data are presented. The title. The title offers a short explanation of what is in your graph. The title of this graph tells the reader that the graph contains information about the changes in money spent on students of elementary and secondary schools from 1977 to 2002. The legend. The legend tells what each line represents. This legend tells us that the green line represents the actual dollar amount spent on each child, and the purple line represents the amount spent when adjusted for inflation. The source. The source is important to give credit to those who collect your data. In this graph, the source tells us that we found our information from NCES. Y-axis. The y-axis has numbers for the amount of stuff being measured. The y-axis usually starts counting at 0 and can be divided into as many equal parts as you want to. In this, the y-axis is measuring the amount of money spent on individual students for public education. X-axis. The x-axis has numbers representing different time periods or names of things being compared. In this, the x-axis measured different school years. Methods of construction. Let's take a look below and get to know in a very simple way how we draw a line graph. Use the data from the table to choose an appropriate scale. All scales start at 0. Draw and label the scale on the vertical axis. Vertical means up and down. Your scale should be easy to interpret. One square or tick mark could represent 1, 2, 5, 10, and so on. A graph unit represents a unit of 1, 10, 20, 100, and 0.1. The scale should not change along an axis. Use a ruler or straight edge to draw your lines. The dependent variable is usually plotted on the y-axis and the independent variable is usually plotted on the x-axis. Draw and label the horizontal axis. Horizontal means across. List the name of each item. Locate the points on the graph. Connect the points with line segments. Write the title of the line graph. Types of line graph. There are two types, open and closed. Look at the tree diagram below. Based on this diagram, you will get to know about different types of line graphs thereafter. Types of line graph. Open line graphs. In these, the points are plotted by means of rectangular coordinates with reference to a point of origin at which the x-axis, horizontal line, and y-axis, which is the vertical line, intersect at right angles. Simple. A line graph which represents only a single series of values connected by a curve is called a simple line graph. Composite or compound. A line graph which represents double or multiple series of values combined with the two different cartographic methods such as a line and a bar or an area. It is done generally to represent rainfall and temperature of a place together. Polygraph. A line graph that shows consecutive observation of more than one variable called multi or the polygraph. Such a graph normally visualizes trends among dense data sets. Multiple line graphs are fancied by many because they're good for comparison and interpretation purposes. Let's visualize one example for that. When population data for more than one geographical unit are plotted on the same graph, it will give a polygraph. Band graph. It is simply an aggregate or a compound in which the trends of values in both the total and its constituents are shown by a series of lines on the same frame. The areas between two successive lines form several bands which are distinctively shaded for clarity. It is also called an area chart or graph. Closed line graph. Climograph. A climograph or the climogram is a 12-sided closed polygon required for plotting the mean monthly values of selected climatic elements of a particular station against one another. The shape and the position of the resultant graph on the framework provide an index to the general climatic character of a place. There are different types of climographs. In some climographs, mean monthly temperature is plotted against average monthly rainfall. In others, monthly wet bulb temperature is plotted against monthly dry bulb temperature. The length of growing season in hours per month against effective monthly rainfall, monthly wet bulb temperature against monthly relative humidity, and so on. They are drawn for comparing climates of different places or areas. Hythergraph. Another type of climograph is called hythergraph, where mean monthly temperature is plotted against monthly rainfall. This is similarly drawn as a 12-sided polygon, just as a climograph. Temperature is shown along the y-axis and the rainfall along the x-axis. The data is plotted month-wise. We thus mark 12 points. Near each point, the first letter of the month concerned is placed. These points, when joined with straight lines, give a closed 12-sided figure. These are principally used in summarizing broad climatic differences in relation to human activity or in the context of settlement. Others. Ergograph. In addition to the above classification of the line graph, another important or so-called compound line needs to be discussed, that is, the ergograph. Ergograph. It is either an ordinary compound or a circular compound line graph representing the nature of work done during the various periods of time in a year. In the case of a circular ergograph, periods of time, that is weeks or months, are shown along the circle. It is a basic type of chart common in many fields. It is often used to visualize a trend in data over intervals of time, a time series. Thus, the line is often drawn chronologically. It can be used to show how something changes over time. They are good for plotting data that has ups and downs or data that was collected in a short time period. Advantages of line graph. They are commonly used in geographic research and analysis as they reveal the relationship between time and other variables in a better way, can compare multiple continuous data sets easily. Interim data can be inferred from graph lines, shows range minimum and maximum, gaps and clusters easily, exact values retained. Limitations. Though line graphs are referred to when the changes are continuous over a long period of time, it still has some limitations that are listed as under. Use only with continuous data, not as visually appealing. Best for under 50 data values. Need small range of data. For graphing equations with decimals or really big numbers accurately through it would be hard. Conclusion. Geography has been immensely benefited from the adoption of statistical procedures in spatial analysis. When the statistics are represented cartographically, either by diagrams or maps, their meanings become clear and lead to a correct conclusion. This is certainly the greatest merit of the graphical representation of statistical data with which results can be derived from figures correctly and with convenience. Thank you.